Okay, everyone, welcome to the Eaglet Eye DirectConnect webinar. This is the last webinar of the year for us. I'm sure we'll have several next year. And we couldn't have a more exciting partner than our friends at Paragon CRT, which is a division of CooperVision Specialty Eye Care. So I'm Ted Newell. I'm one of the U.S. business development managers here in the United States, and I'm going to help host this webinar tonight. And we're really fortunate to have two experts on Paragon CRTs with us this evening. And one is Rolando Ortiz. And Dr. Ortiz has a practice in Cary, North Carolina, where he's had a private practice for 10 years. It's a vision source practice called the Bright Vision Center in Cary, North Carolina. He's a graduate of the Inter-American University of Puerto Rico School of Optometry, and he is not only a Paragon CRT user, but he's also he's a scleral lens user, so he has experience with both sets of lenses, types of specialty lenses in his practice. Also tonight, we have with us Dr. Kelly Voltz, who is the Senior Manager, Professional and Clinical Affairs at CooperVision Specialty Eye Care. So she will be walking us through the Paragon CRT. She's got some excellent slides and some excellent information for everybody. So I'll start just first talking about the eye surface profiler. We call it the ESP for short. And then after I talk about the eye surface profiler for a few slides, I'll turn it over to Kelly. And then when Kelly's done, she will turn it over to Rolando. And at the very end, we can take questions. If I see a question that comes up in the chat that is really specific to somebody's presentation, I may interrupt the presentation and say, Dr. Voltz or Dr. Ortiz, so-and-so asked this question. Can you answer that? Or we may save the questions for the end. It just depends on the nature of the question. We have a lot of people from a lot of places, people registered from over 40 countries. I'm sure due to time zones, not everybody's going to be able to make it. And for those people, we will have a recording. But welcome everybody to this webinar. We really have a lot of fun with these things. We are lab neutral, but the advantage that CooperVision has with the Paragon CRT is even though we're lab neutral and we serve or work with over 20 labs and with over 40 lens designs, we're the only company that does that. Paragon has the unique advantage right now of being the only CRT lens we work with. So that's pretty unique. And we'll talk about that in a few minutes. But the eye surface profiler has already revolutionized the way sclerals are fit. And I wouldn't be surprised that a number of the people attending tonight are ESP users who are interested in the ESP and probably have heard about us in terms of our ability to help with scleral fitting. And there are a lot of advantages, and we'll talk about those in just a second. But the same precision can now be added to ortho-K fitting because you really want to see very clearly what's going on with the cornea and the limbus to get a good corneal or ortho-K fit. So in profilometry, it's what we're doing is we're getting all the data of the cornea, limbus, and sclera in one shot. There's no extrapolated data. We're not averaging images. So if you want to see, like in this image right here that's floating around, you can see a pinguicula. Or if there's scleral lacerations, or if somebody has had corneal surgery and that creates some difficulty in fitting a regular lens or normal lens or using spectacle lenses, then fitting a specialty lens like a scleral lens is really important and provides a lot of value. And of course, it's great when you have all this data. The eye surface profiler is what we call technically a corneal scleral topographer. Like I said before, we call it the ESP. And you get full cornea, limbus to limbus, and sclera coverage up to 20 millimeters in diameter. Like I said before, no extrapolation or stitching or averaging. We gather about 500,000 data points, and our accuracy at the cornea is 2 microns, and at the sclera is 10 microns. So our accuracy and height data is quite significant. It's real comprehensive, and we won't have time tonight to go into all apps and calculators and the various parameters that the ESP can deal with. You'll get exposed to some of them. If you want to learn more, you can always ask us for a virtual demonstration, and we can go into more of these various maps with you. But tonight, you'll get a really good introduction to the technology, especially related to ortho-K. How does it work? Well, what we have is one camera, which you see in the middle of this central image right here where my cursor is. And we have two cobalt blue lights that shine light on the cornea. And of course, we get the image reflected back to the camera. To get the height data using this technology, we use Fourier transformation, and that requires fluorescein. So we always put fluorescein on the eye when we're taking a measurement. And so here you can see where the eye has been excited. You can see all the vertical lines that are the data that the camera is taking and putting back into our software, so we can create a beautiful map like the one you see on the right here, and this is a great map. It's a great image of the eye. And what you see here is the cool colors are deeper, the bright colors are higher. And the reason that we have this ring where the limbus is because you have two curves coming together. You have the corneal curve and you have the scleral curve intersecting, and that creates a red line. But you see all the data if you're ever looking at one of these images, or if you do a virtual demo for us, or if you're a ESP owner, you know exactly what I'm talking about. You can get all the data by just simply putting your cursor anywhere on that map. Now, for the sclera, the advantages of profilometry, again, is that we have this wide coverage, and the measurements are fast, and they're especially fast because we're not stitching together images. And we typically take 3 images. We recommend that so that you can pick the best of the 3 images. We're not taking 3 images to average data. We're taking 3 images so you can pick the best one. And our new software, by the way, has some, I don't know if we'll see that tonight, but our new software actually has quality control indicators like little green, yellow, and red lights at the very top of the image that will help tell you which images are best. And our customers really like this new piece of our software. But for the sclera, with this data, you get precise and complete data, which really makes a difference in terms of your haptic designs and any places where you might need to vault, like a pinguicula, or if there's a certain kind of scarring. Now, for the cornea, the great thing about profilometry is we cover the entire cornea, limbus to limbus. You don't, because the instrument stands back a little bit from the eye. We're not on top of the eye like some other instruments are. We're a little bit back from the eye. We don't have these shadows from nose and eyelashes if the eye has been opened correctly. But here you can see the circumference of the cornea, and you can see the circumference including the limbus. And of course, we're gathering all that data. So you get precise, complete data to help you plan your return and your landing zones with ortho-K. Now you compare that to this. So this is a typical Placido ring topography image that we've overlaid on our eye, and you can see that the data isn't absolutely complete. And that's a challenge that you might have with certain topographers. But with the good old ESP, we get everything. And so it ends up being a tool, a device for specialty lenses, whether you've got keratoconus and you're treating it with a scleral lens, or you're trying to help somebody. These are images, by the way, the keratoconus image is courtesy of Barry Leonard on the left, and the ortho-K image on the right is courtesy of Dr. Sheila Morrison. So whatever kind of specialty lens you have, we can help you out. And even though we've got the DirectConnect, which we'll talk about again here shortly, the The advantage right now, of course, is with the Paragon CRT. And it's because if you're using our instrument, send the data to the Paragon CRT consultants, they see exactly what you're seeing. However, if you did need to use a different lens for some reason, you could. You've got all the topography data of the cornea and the limbus that you can take from the instrument, and you can provide that to any lab that you want to. Like I said, we're lab neutral. We work with lots of different companies and lots of different lens designs. And of course, tonight we're featuring the people at Paragon and with their fine lens. And what I was talking about a second ago is what we call DirectConnect. And that is that when you are finished, and I think you'll actually see one of these prescription slides when Dr. Ortiz makes his presentation, but you actually hit the DirectConnect button. All the data that you've collected is pre-populated into the Paragon CRT prescription form. All you have to do is put in your practice information, your account number, and you have to answer a few more questions related to this particular patient. Then you click submit, and it's on its way to the people at Paragon CRT. And like I said, they have our software and they get that data. It's called an MRS file. They get that data and they can open that up and they can see exactly what you've dealt with. And they may have some advice for you. You might have a perfect prescription and they can take it away from there and make your lenses, or they may have some advice for you. And now when you talk to your consultant, you're talking apples to apples. Like I said before, we're focused on all specialty lenses. We have this thing called a first lens fit algorithm, which you'll see used a little bit later tonight. And that's a way of having the ESP and its software in association with the labs help design the lens for you. And it really takes a lot of effort away from you, speeds up the process, makes it faster for you, for the patient, and the result is a better fit. We do have what we call an Eaglet Eye Academy. And this academy is really helpful. It's a virtual academy that our practitioners and our customers can go into anytime, and they can learn how to use the ESP, or they can, if they have a new technician, the new technician could go in and learn about it. If they have a little turnover in their office, we have videos, but we also support the virtual learning with Zoom calls from our professional affairs managers back in the Netherlands. And those people always are there to help, because at the bottom left-hand corner of any one of our exams that you see, when you're doing an exam, you'll see a button that says support. And if you click on that button, you can send all the data from that particular scan to us if you have a question, if you're having a problem or a challenge, and we'll give you our advice. So you not only have the Eaglet Eye Academy, which is an e-learning center, but you also have the people at Eaglet Eye to back you up. And with that, I'm going to turn it over to Dr. Voltz to let her tell us about the Paragon CRT. She's got some great slides here. Kelly, I'm going to turn it over to you, and I'll mute myself. And like I said before, Kelly, if you need me to do anything like show a slide again, just tell me to do it.
Great. Thank you, Ted. Hi, everyone. It's great to be with you all this evening. Before Dr. Ortiz jumps into some case series using the Eaglet and Paragon CRT, we're just going to review some of our lens parameters, so we're all speaking the same language here when we go to troubleshoot lenses and lens fit for our patients. So we'll go ahead and jump in. As a reminder, Paragon CRT was FDA approved in 2002 as the first ortho-K lens available in the US, and it is currently on the market today, correcting up to -6 diopters of myopia and up to 1.75 diopters of astigmatism. I always like to show this slide because it's a really good reminder of who our easy patients are and maybe who our more challenging cases will be. We also have different FDA-approved materials for overnight wear, including Paragon HDS 100 and Menacon Z. So we'll go ahead and take a look at the lens design on the next slide. The Paragon CRT lens design is made up of 3 main areas or zones. The most central area here, the gray portion, which aligns with the central flattened area of the fluorescein pattern, is our base curve or our base curve optic zone. We have the ability to customize this optic zone not only in curvature but also in the diameter. So Paragon CRT is offered in both a 5mm and 6mm diameter optic zone. The second area of the lens here that you see in purple is called our return zone. A lot of times you'll see that abbreviated as the RZD for return zone depth, and we'll review that that's the sagittal depth of our lens. And then lastly, we have the landing zone angle, which is this blue portion of our lens. And you'll notice that as it aligns with the fluorescein image, it accounts for that outer dark area where the lens is landing or resting on the patient's cornea, as well as the amount of edge lift that the lens has. We also have our Paragon CRT dual axis lens design. This is a dual depth meridian specific design. And so you'll notice here that there are potential for a dual return zone or a dual landing zone. So imagine this as a great design for patients who have apical astigmatism or limbal to limbal astigmatism. We have more options to customize the different meridians so that that lens fits well and is able to center that base curve optic zone. So who do we recommend the CRT dual axis lens for versus the CRT lens? We can go ahead to the next slide and we'll see a few examples or the most common reasons why a dual axis lens will be recommended, whether that's through empirical calculation, through consultation, through topography driven designs. So most of the time when a patient has greater than 0.75 diopters of corneal astigmatism, you'll see that a dual axis lens is recommended, but it might be also recommended as a troubleshooting option. So you'll see in the middle picture here, we have a great example of an inferior central island there. And so sometimes just having a dual axis lens will allow that lens to stabilize more on the patient's eye and result in a smoother treatment pattern. Another telltale sign of the need for a dual axis lens is what you see in this fluorescein video here. So we can notice at the 6 o'clock position, we have what we see as like a tear channel. So 3 and 9 o'clock, we have that picture perfect bullseye pattern. And Ted, if you don't mind playing the video one more time, I think it's really noticeable after the blink. But at that 6 o'clock position, we don't have that lens landing or aligning or resting on the patient's cornea well. So by utilizing a dual axis lens, we can optimize that fit for this patient. So the first area of the lens that we talked about is our base curve or our base curve optic zone. That's this gray, most central portion of the lens here. And for myopia correction, we're generally going to be prescribing a flatter base curve than the patient's flat K. The base curve is measured in millimeters of radius. And how do you know if you have the right base curve for your patient? You need to remember to measure the refraction over top of the lens. This is specific to Paragon CRT and CRT dual axis, but we recommend an over refraction of about +50 to +1. It can be something easy to forget. You put the lens on your patient, you want to go ahead and take a look at the fluorescein pattern, but just remember to do a quick +50 check. So I just usually throw up the 20/20 line and monocularly we'll check VA. I like to use loose lenses or flippers. That's just what seems to be most easy for pediatric patients. If we need to have more myopia correction, we're going to go flatter on the base curve versus if we're overcorrecting, then we're going to steepen the base curve and back off that cornea. And I believe in the next slide here, we'll see an example of that. So for this patient, they had an 8.8 base curve and we got a refraction over lens being plano. So if we were targeting a refraction over lens of +1, we're about a diopter off with that 8.8 millimeter lens. And so remember, for every 0.1 millimeter, it's a half diopter change. So the new base curve I would order for that patient is a 9.0. This is really important. This is something that doesn't get better with time or longer treatment or more wear from 1 day to 1 week. So if you notice that the refraction over lens isn't in that target range at the dispense visit, then I recommend go ahead and ordering that new base curve so you can swap it out at the 1 week follow-up visit with your patient. And the next area of the lens that we'll talk about is the return zone, or the RZD, return zone depth. That is the purple area of this lens. And if we go ahead and play this video, you'll see the kind of principle of how decreasing RZD brings that entire lens closer to the eye. So a 600 RZD is going to have more sagittal depth than a 500 RZD. And just notice we're not changing the actual curvature or shape. We're just actually lowering or lifting that lens away from the cornea. So you'll see that the RZD is available in 25 micron steps, and you'll also notice it being listed twice in our dual axis lens design. So what does this actually mean or translate to on fluorescein pattern? We can see some examples on the next slide. So if we look at this middle picture and we consider this our ideal bullseye pattern for ortho K, if we were to increase the RZD to this picture here on the right, you can notice now we have a lot more tear film or area between the back surface of the lens and the front surface of the cornea. So we're seeing a lot more tears that are pulling in that area. We're also noticing some bubbles, almost like it's a steeper fit. Versus if we decrease the RZD and we go in the next direction, now we've lowered that lens much closer to the patient's cornea. So we see that that fluorescein in the return zone is a little bit harder to appreciate, and it's a little bit more faint. These are pretty extreme examples. You're not normally going to make this large of change with your patients, but hopefully it gives you a really good idea just from seeing the images of what an RZD change will look like. Normally, again, we'll just make 25 micron changes at a time. We'll go ahead to the next one, which is our very last outer portion of our lens, the landing zone angle, or LZA. There's a lot of numbers on this slide, and the easiest way to remember it is if the horizontal from the purple is considered 0, if we flatten the lens edge, that edge profile will go closer towards 0. So a 32 is flatter than a 33 or 34. This also will have a slight change in sagittal depth. It contributes about 15 microns per 1 degree change. But ultimately, our RZD is our main sagittal depth contributor. But it's important to note if you are making multiple changes in your landing zone angle. So what does this look like on fluorescein pattern? Kind of a quiz for all of you. If you were to look at these and just think of this as a corneal GP lens, I normally ask students when I'm teaching, what do you think of the 34 on the right-hand side? Most of the time I get an answer that it's minimal or doesn't look great. It looks kind of thin. And if this was a corneal GP and there was no corneal staining, you might be comfortable with this lens edge. But for ortho K, we really need tear exchange in order for those hydraulic forces to work. So if you kind of go ahead and go through these animations, Ted, we'll see this is sort of my Goldilocks version of ideal edge lift that we're looking for in a Paragon CRT lens. And so in this example, that 34 is really minimal. We're going to see slow treatment. We're not going to have a lot of tear exchange underneath this lens. Dr. Ortiz even mentioned at the beginning here when we were chatting before the webinar, it can lead to the lens binding or even getting bubbles trapped underneath the lens, dimple veiling. So we really want to aim for about 0.5 to 1 millimeter of edge lift. And that's what you see in this middle 33 LZA picture. 32, you're going a little bit overboard. Your patient's probably going to experience some discomfort in a lens like this that has about 2 millimeters of edge lift. So if you're new to fitting ortho K and CRT, I actually recommend that you just use the 1 by 1 millimeter beam on slit lamp and put that over the lens edge and ask yourself, does this take up at least half my beam? And you just do that for the first 3 to 5 patients, and you kind of establish this new normal of what edge lift should look like in an ortho K lens. All right, so just as a last review, what are we ultimately looking for during our follow-up visits for Paragon CRT? Ultimately, we want to see that the lens is well-centered. We want to see that it has really great corneal coverage. If you notice this lens here, we can go ahead and play this video as well. We really want to optimize centration by optimizing the lens diameter. And this is a great example. We're really shooting for about 95% of corneal coverage with our ortho K lenses. You'll also notice this lens has really great uniform landing. So that's that outer dark circle beyond the return zone. And then we also have really great edge lift. So hopefully this will be a good preview for our upcoming cases.
Thank you very much, Dr. Voltz. Really great animations to show us how the return zone, the landing zones work, and especially that edge lift. So again, thank you very much. Really appreciate your participation and also your help at the end when we may have some questions. And so now I'm going to turn it over to Dr. Rolando Ortiz. And if you've unmuted yourself, have you unmuted yourself, Dr. Ortiz?
I did. I'm ready to go.
Or we'll dive right into the first slide.
Welcome, everyone. Good evening. I would like just to mention something very important. I would like to share how I use the ESP to speed up the process in a daily life practice. We are all busy. We're always trying to maximize our time, improve our chair time so we can see more patients and be more proficient on what we really do. So using the ESP has actually increased the success of a first lens fit or maybe a second lens fit versus changing multiple times and multiple visits. So that's why I would like to share these couple of cases and explain how the ESP has facilitated me and my practice to improve the flow pretty much. So on this first case, 13-year-old female has been my patient for a couple of years now. And as we can see, in 2019, she had a minus 150 myopia and a 225 on the left with some cylinder or astigmatism. She escaped 2020, and all of a sudden we had a good increase in 2021. And then by 2022, we had a minus 3 and a 375. At this point, I suggested to do some kind of myopia management, and also the parents were looking for some better quality of life, some freedom for their kid. She would like to do more sports. She would like to do more active hobbies on her free time. So the parents and I pretty much agreed to work on CRT lenses. So after considering different options, because of the freedom CRT will actually give this patient, the parents opt to or choose to go with the CRT treatment. And I like to explain to my patient, to the parents and the patient too, of course, that we'll be knocking out two things. One of them will be their vision and controlling progression and improving quality of life too. So that is super important when you have a very active kid on the chair. This is a quick chart that I use to kind of rule out which therapy I should use. So already my mind is already set, so I go through this process very quickly. But this is something that helped me out guiding myself at the very beginning, which way I should go ahead and treat this patient. It's too young, it's too old. So pretty much after cycloplate refraction, we confirm that the patient is myopic. We check if there's any binocular issues. If not, we can move on. If it is older than 6, we can then go ahead and consider any kind of CRT treatment according to the FDA standards. Also, in the other chart, let me actually, there you go. This study here on the right is using the pupil size as a guidance and the myopia, the amount of myopia, to see which is the right way to go to control or manage the myopia on the patient. For example, a 4.5 millimeter pupil or bigger with a higher 250 or higher myopia. An astigmatism less than 1 is orthokeratology treatment, option 1, or a soft multifocal was the option 2. The other thing that we can do, and again, I would mention this because in the next slide, you will actually notice something when we get to fit the lens. The ESP will do this for you and will select the lens for you according to the results of your images. That's why it's so important to get good quality images, so we will get a better recommendation by the algorithm. But for example, when we get to the Sarctoricity at 8 millimeters, then if it is less than 30 microns, we go to a toric or a dual depth return zone. And then at 10, we double check again. If it is less than 45, we go into a spherical alignment. Or if at 10 is higher than 30, then we go to a dual landing zone. But on the next slide, this is what I'm talking about. When you get your good quality image, you can move on to the Court 8 millimeters. And here on the difference, it will tell you how many microns. And here is in millimeters, but in microns. And that's how these will process all. And it will show you a spherical fitting versus a dual axis. Then in the next slide, it will show you the 10 micron slide, and this one is less than 30. This one will show you that the lens that will be designed or choose or calculated by the algorithm pretty much will be a dual axis lens. This is the easiest part. Pretty much you just, according to your image, you calculate the lens, and then you will actually add your prescription, and then you just set as a baseline, and then just hit DirectConnect. Another concern that I found from other colleagues back in October when we went to a meeting, how the kids are behaving, how they behave when we're taking the images, because we want to get very good quality images to be able to be as accurate as possible. I was planning on taking a video, but the patient did not show today. So I'm sorry, I apologize for that. But kids are amazing. All the kids that have been doing the fitting through the ESP have been so cooperative, and they behave very well. They open their eyes very wide. Remember, we just need limbus to limbus, vertical and horizontal. We don't need the full scleral topography for this. So even with one hand, you can do it with a good fluorescein coverage. And they tend to help me out very well. So that was one of the main concerns from other colleagues, how they stay put in place to take good quality images. But the kids are amazing. Kids are amazing. So going back to the case, after you just taking all the baseline images, you will hit DirectConnect, and this will transfer all the information over to Paragon CRT. And it will send me over the first lens design according to the image. Now, on this one, the first lens was designed with a 9 base curve on the right and 9.3 on the left. And you can move to the next slide, Ted. This is my protocol. I won't repeat this again, but I show a video, CRT video, how to do insert removal. We follow up in 1 day and then 1 week. And that's when I decide if I make any adjustments. If I notice something the first day, I can do a quick order. But most of the time with the ESP, it's pretty good, the first fitting. So most of the time I let them go for 7 to 10 days, which is a recommended time. Remember that the corneal hysteresis will play a role. Some patients will take a little bit longer to reach a good treatment zone. This patient after a week was actually was very good. Ted, you can move to the next one. I would like to show you here real quick. This is a follow-up ESP image. You can see the pattern. And here on the power profile, you can see the change on the treatment zone on the lower left. That was the right eye and the left eye images. So that was pretty accurate. And we finish up pretty much with that lens at the end after 3 weeks. There was no change. Patient was in 2020. And actually, that is actually a real picture of this patient. He's actually, we had a slit lamp. There we go. So this other case pretty much was Kind of the same scenario. Patient was initially seen at 2017. Now she's 10 years old. Minus 2.25 and 2 when she was 6 years old. Now you can see the progression here at the bottom, even though was strongly suggested to start any treatment for myopia control back then. The parents refused to. Sometimes we don't understand why, but it happens more often than what we expect. But some parents they don't accept what's going on until they see their kids actually struggling in real life. The change from 2019, pretty much from 17 to 2019, it pretty much double up, almost double up in both eyes in prescription. Yes, pretty much the parents were not accepting it back in 2019 still, until 2020, pretty much, when they noticed that their kid was actually struggling in real life. The prescription went up to a 525 and a 475. And I tried to explain to them, we did the basic stuff, pretty much atropine and then ISM plus 4. That was the best I could do with the parents agreeing with. Now 2021, finally the parents decided to do a CRT fitting. In 2021 I did an empirical fitting. I was just barely starting at the very beginning of the year, and we actually struggle with comfort. The lens was a little bit too tight. I didn't realize what she was trying to tell me, but after a couple of visits, we realized the cornea was a little bit with baleen dimpling and also a little bit of SPKs in the center, and that's why it was uncomfortable for her. So when she came over to 2022, she was about to quit, and I told him, hey, hold on, let's do a new fitting. Let's wear off all the treatment. Let's do the ESP measurements, and with the ESP measurements, actually we improve with the first lens. The comfort was improved drastically. She was able to take them off in the morning, no hurting, no pain, no discomfort at all. We finish up. This is an example of the alignment on these pictures, and these actually her pictures. And based on this image, we actually sent over the first lens for the refitting in 2022. Now, again, as I mentioned before, if we use certain tables or flow charts to guide ourselves, ortho-K, according to pupil, was the best option. Also, I would like to point out, if you have a very progressive patient, a myopia progressive patient, there's two different zones or optical zones or treatment zones on CRT. On these ones, we usually like to use smaller pupillary zone or optic zone, I'm sorry, of 5 millimeters to improve the peripheral defocus, which provides a better myopia control versus a bigger optic zone. You can move to the next one, Ted. Again, the algorithm will do this for you, but if you'd like to see numbers and see why it did calculate this, if it flow in the 8 millimeters, if it is more than 30 versus less than 30, it will guide you through a spherical fitting versus a dual landing zone or fitting. But you can move on to the next one, Ted. Again, as a review, it will actually, you can move this 8 cord or to a 10 and then check the difference. How much is that difference? And then it will tell you which lens will be a better fit. Pretty much the lens here on the right, it will show you that the ESP did calculate a dual axis lens. And this is the first lens that we order. We have a 10.5 diameter on the right with a 9.0 base curve, and the 9.0 on the left with a little bit bigger diameter on the left eye. And we calculate this according to HBA ID that is measured by the ESP as well. You can go to the next one, Ted. This is the difference in power in a follow-up for this patient. So I would like to point out we have a great centration here, but in the edge, pretty much you see how the edge looks. We need a 0.5 to 1 millimeter clearance on fluorescein pattern to permit a pretty good tear film flow underneath, overnight. If not, the central cornea can be a little bit, uncomfortable. The next morning we'll be a little bit irritated, or by bailing, or we can actually have some SPKs if we don't have a good tear exchange overnight. And in here, the edge is fairly good. The treatment zone was a little bit smaller, and we at the end pretty much change the base curve just a little bit on the right eye. We move from the landing zone pretty much to increase the lens edge a little. And on the left eye, we went from a 9.0 to a 9.2 base curve to improve the treatment zone. But everything else, we pretty much kept the same. This was a 2-lens fit, and that was it. Patient was having a great vision, great comfort. So think about if you have been doing empirical CRT lenses, if you're not, you're just learning, and you would like to maximize your time. I was encountering myself dealing with 3 changes, sometimes even 4 changes, to make it, perfect, the way that I was looking for. Now these, with the ESP, I was able to achieve that in a high prescription with the second pair. So this was a great case, and she was very happy, and she has been successful. I have been following up on her, and she's still 20/20 up to this day. You can move on to the next case. Perfect. The case 3, pretty much same case scenario, patient increasing from 2019 to 2021. This patient did disappear for a couple of years. When he came back, he increased in prescription, and they were concerned because now he was having certain limitations. We went through the process, and we actually was looking to get a better myopia control. And we finished up agreeing with Ortho for myopia management. You can go to the next one, Ted. It goes to the chart flows pretty much. In this one, if we choose to follow the pupil with the Montreal study, it's interesting. It actually, the corneal ortho or custom ortho K is a great option. And what I'm talking about is pretty much a smaller optical zone to better manage the myopia control. And this is an example of the quality images that we took. We plug in the numbers, and then we hit DirectConnect, and this will send over to CRT or Paragon. You can move on to the next one. And this was actually our first lenses that were calculated. This case was very interesting, and I have had a couple. We were able to achieve in 1 week pretty much 2 diopters of correction. Good centration. Patient was 20/20, and happy. Corneas were in great shape. The images, the fluorescein pattern was amazing. I just follow up on this young fellow recently for a 6-month follow-up, and he's still 20/20. No discomfort. Patient is very, very happy. Now, I think that we still have one more case. You can move on to the next one. Perfect. This one actually was not for myopia control. This was mostly for quality of life. Young 18-year-old male with starting to work overnight, actually. So he was struggling with his vision. His brother, his younger brother, which is 14, had CRT before for myopia control, and he was very excited about being able to correct his vision. So you can move on to the next one. Let me show them the prescription that we start with. And this one, according to the corneal astigmatism, was a dual axis right away. Also, I would like to point out that in this image, as long as you have a good coverage of the limbus to limbus and a good centration and alignment on the horizontal and the vertical Purkinje reflex, you should be able to get a very good quality image. This will help you out selecting the lens according to the central 8mm versus 10mm. And you can tell, according to this, that it will be a dual axis fitting. But again, the ESP will calculate this when you plug in all the and process the images and plug in the prescription. Perfect. So this is actually the calculated powers that were given to us by the ESP, and then we send this over through DirectConnect. You can, and this patient actually, you can move on to the next one. These are the difference in curvature. Very flat corneas here to the right, left bottom on both images. You can see the only thing that you can appreciate on the follow-up on the left eye is a tiny, tiny little central island. But again, this patient was seen 2020 and no discomfort issues, no glare issues at night. We actually adjust the lens once on this case. And this lens actually, before I let you guys go, this was very particular. After this adjustment, we were able to make him see very good and constant. After the first lens, this one actually changed to only one change. But it was because the lens was not, the vision was not lasting at least 10 hours that he was looking for. So we actually flattened the base curve a little, and then we were able to achieve the 20/20 vision that he was looking for a long period of time. And we found out that I had to let this patient actually, due to his corneal hysteresis, it was kind of resistant to change. So I had to let him wear these contacts for 2 weeks before I was able to make any adjustments. So that will change to patient. But after 2 weeks, we're able to mold that cornea to the right amount of power needed for him to last a good amount of time. Well, have a great evening, all. This is it. If you guys have questions, you guys can shoot them to us, and we'll stay for a few more minutes.
Absolutely. So, Dr. Voltz, if you would unmute your microphone, and Dr. Ortiz, if you'd stay on. Yeah, we did have some questions that I don't know if I said at the beginning, but way over in the Netherlands, where it is almost 3:00 in the morning, our director of marketing, Elena Barrios, has been diligently answering questions and letting people into the program. So, Elena, we really appreciate your support, especially in the middle of the night. Thank you very much. So one question that I think Elena answered it, but I'll just go ahead. She answered a bunch of questions that were specific to the ESP, but one doctor asked, I know the Jessen factor plus 0.5 or plus 1.0 can be customized through the ESP. How about the optic zone? Can it be manually selected to be either 5 or 6 millimeters?
Yes, you can do that. There's a lens that you want to do the CRT lens or the smaller millimeter before you calculate the lens. You can select that optic zone treatment or treatment zone.
Okay.
Before you calculate and send over.
And I'll add that is available for both a CRT lens or a CRT dual axis lens. You can customize the optic zone or Jessen factor for either of those lens designs.
Yes.
Okay, excellent. And some of the other questions Elena was taking care of along the way. We had a number of questions earlier. And if there aren't any other questions, I think we can wrap this up. Do you have any final thoughts, Dr. Voltz?
No, I think the cases were a really great example of being able to just start with a really great fitting lens from the beginning, and then troubleshoot as you go if needed. But I especially think the cases that paid good attention to edge lift of the lens, refraction over the lens, just making simple base curve changes, making sure that you collect that data at your follow-ups will help you not only from the beginning in the design of the initial lens, but also really help when you start working with consultation and providing them that information. So thanks, Dr. Ortiz.
Yeah, I was actually surprised when you're going through the cases, Dr. Ortiz, that you have to be partial psychologist. As these people, you sort of wait for them to go through this progression and go through this time. And sometimes patients have to figure it out themselves a little bit. They're offered everything, but they have to figure it out themselves to decide what's finally best for them. And you can actually act and do what's best for them. I think that's pretty impressive.
It is very challenging because it's not only the patient, also the parents, because they're still kids. For myopia management, the 18-year-old was like, yeah, I want to do it. And he was able to make the decision. But on the younger patients, it's a challenge because some of these parents are not myopic. They don't know how their kids are seeing, and they don't know how blurry they are in real life. So it's a real challenge, but it's rewarding. It is.
Yeah, I can imagine. All right. So I think that's can we decrease the optical zone for myopia control using ESP data? There's another question we have here. Or how can we decrease the optical zone for myopia control using the ESP data?
I think Dr. Swarner's question was referring to when we're using ESP data. So selecting your optic zone will be considered an input. Just like you're putting in the patient's prescription, you're going to designate what optic zone you would like for that patient. So you can select either 6 or 5, and then the ESP data or the shape of the eye is what's going to be used to help calculate the lens parameters. And you'll also see that optic zone input that you selected in your output. So you'll see if you requested a 5, they'll use the map from the ESP to design a 5mm OZD lens for the patient. Hopefully that'll answer the question.
And I think a key component to the answer that you just gave, Dr. Voltz, is that you can use the map because you have the map, because the doctor sent you that data, and now you have that to work with to help them design an eye that might be, or design a lens for an eye that might be a challenge. What will be the ideal optical zone for myopia control and management?
Not actually. If it is a very progressive, what they're suggesting is to get the smaller optical zone as possible, because you want that peripheral distortion to be bigger. On the vision by design training, we went through so many studies. But that peripheral defocus, as bigger that defocus and more concentrated the central image is, and that peripheral defocus as big as it could be, the best myopia control shows on the fitting. So a smaller the optical zone, better. Dr. Voltz, anything else about it?
No, I can add just information from our clinical data regarding the 5mm optic zone. We show that it works slightly faster, just in terms of the actual myopia correction. So at a 1-day visit, on average, we see about 0.5, almost 0.5 diopters more correction. So it has that added benefit of working slightly faster. And then we will also see a smaller treatment zone size on the cornea, which Dr. Ortiz, you just referenced, as well as increased paracentral steepening. So more of that mid-peripheral red on your post-treatment topography maps. So we'll see that in addition to the smaller treatment zone size. So those are just like 3 aspects or takeaways that I have from the 5mm lens design.
And then let's see if we have any ortho-K lenses of 4 millimeter optical zone will this be helpful?
So Paragon CRT and CRT Delaxis are only available in the 5mm, 6mm OZ. So our lens design does not offer 4mm. 4mm is quite small, though. You have to remember that on average, the treatment zone on the cornea is going to be much smaller than the actual optic zone of the lens. It's not like the optic zone is a stamp, right? We get a 6mm optic zone and a 6mm treatment on the cornea. It's actually much smaller, to the degrees of closer to like about a half. So if I think of like a 6mm lens, and I'm just making up an example here, giving closer to like a 3.5 or 4mm treatment zone, a 4mm OZG is going to create a really, really tiny treatment zone size on that cornea. We do not currently offer that at this time.
And Dr. Yoon said if it's too small, perhaps you get some halo.
And yes, that's right. Also, remember, these are designs in clinical life. You have to look through the topography, and you can look at the pupil's size yourself. And also, if the patient is driving at night, if the patient, if we're fitting an adult versus a kid for myopia control, if it is a smaller optical zone in a driving age patient, it might have some glare and halos at night because you increase the peripheral defocus. And so those are little things that will come in play as you learn how to fit the lens and increase patient comfort at night versus vision and all that kind of stuff. But yeah, absolutely. If I have an old patient or not an old patient, that's 17, 18, 20, that would like to do CRT, then we can do a 6mm, and it will help reducing the glare at night, and it will be better than a 5 for that patient, specific patient, of course. So our clinical criteria will come in as well, clinical decisions.
Okay. So I'll try to wrap this up here really quickly. And the whole point of the ESP working together with the Paragon CRT is better fits, which means you get happier customers, more customers, happier staff. Everybody in the practice will be happier. Fewer refits, which means less chair time, which means you can devote that additional chair time that you gain to either more ortho-K patients or scleral patients or patients for some other reason, and a faster process. But these are the contact points if you need to contact us at Eaglet Eye or the fine folks at Paragon CRT if you'd like to learn more about their product, have one of their people calling you, or if you want a virtual demo from somebody at Eaglet Eye, we'll be glad to set that up for you. And with that, I'm going to say thank you. I really appreciate the support from the Netherlands, Elena. Dr. Ortiz, great cases, very interesting. I think it really showed the scope of the Paragon CRT. And Dr. Voltz, thank you very much for taking the time tonight to join us and to help us better understand the wonderful product that you guys make and how it works and how it benefits the patients. And
Thank
with
you.
that,
Have a great night.
yes, thank you. Thank you, everybody. Have a great night.